Hey there, and welcome back to The Explainer. Today, we're taking an explosive deep dive look into Palantir's modern defense ecosystem. If you've been following the defense sector at all lately, you've probably noticed that the entire landscape of warfare is fundamentally shifting. We're moving away from just relying on raw hardware and moving heavily into software. So, today we're going to unpack the exact tech stack making this shift possible. We'll explore how Palantir literally connects data, artificial intelligence, and battlefield operations into one seamless reality. Okay, let's dive into this. How in the world do you compress a military kill chain from hours down to just 86 seconds? During a real-world military engagement called Operation Epic Fury, that staggering compression wasn't just a theory, it actually happened. But here's the kicker. It wasn't achieved with a newly designed missile or a faster jet, it was done entirely with software. Let's look at exactly how they pulled that off. To get us there, here is a quick roadmap for today. We'll start with the fragmented battlefields problem, then look at Palantir's foundational data engines, Gotham and Foundry. From there, we'll get into AI targeting with Maven and Titan, figure out how they deploy it all securely using AIP and Apollo, and finally, wrap up with a broader strategic advantage. All right, part 1, the fragmented battlefield problem and how we overcome data silos in warfare. See, before modern software integration came along, military decision-makers were essentially drowning in isolated data. Imagine trying to manually monitor up to 9 totally separate, fragmented systems at the exact same time. An analyst would literally have to pull satellite imagery from one computer, look up signals intelligence on another, and then manually hand off that info. It was a slow, error-prone process that often took hours. Contrast that with Palantir's ecosystem today. One unified interface. It uses AI data fusion to bring all those chaotic streams into a single crystal-clear view, slashing execution time down to minutes or even seconds. Which brings us right into Section 2, the foundation, Gotham and Foundry. This is the massive data integration engine powering everything. And this brilliantly illustrates what Gotham actually does. Gotham is Palantir's flagship defense and intelligence platform. Think of it as map-based intelligence fusion. It takes mind-bogglingly complex multi-source data, stuff like live video feeds and geolocation pings, and instantly integrates it into a single operational landscape. It essentially serves as the ultimate common operating picture for commanders on the ground. And just to be clear, Gotham isn't some new experimental beta test. This platform easily handles the highest levels of classified military data, and it's been a core defense platform for over a decade. Heavily used by the U.S. Army, Special Operations, and NATO allies, it enables real-time command decisions by fusing battlefield intelligence directly with high-stakes counterterrorism analytics. But, having the intelligence picture is only half the battle. That's where the Foundry defense stack comes in. Foundry manages the incredibly messy, complex world of military logistics. Because knowing where a target is doesn't really matter if your supply lines can't support the mission. Foundry optimizes those supply chains, manages mission planning, and runs predictive maintenance analytics. By using what's called a core ontology-driven architecture, it basically creates operational digital twins of military assets. That way, when an operation goes green, the supply lines and the intel are perfectly synchronized. Moving on to Section 3, AI targeting. Maven and Titan. This is where things get really cutting edge, compressing that kill chain. Take a look at this beast of a vehicle. This is Titan, short for Tactical Intelligence Targeting Access Node. Even though Palantir is a software company, they're the ones delivering these next-generation AI-defined mobile command vehicles for the U.S. Army. Titan is basically the ultimate tactical edge node. It grabs deep sensing data from space, air, and ground sensors, processes all of it right there in the field, and links that intel directly to ground weapons. It's essentially a rolling data center, meaning frontline troops don't have to wait around for some distant headquarters to analyze their intelligence. Now, to really appreciate what Titan and Palantir's software actually accomplish here, we need to quickly understand the traditional military kill chain. It's known as F2T2EA. That stands for find the threat, fix its location, track its movement, target it with an appropriate asset, engage with force, and finally, assess the outcome. Historically, navigating these 6 steps across silo departments used to take anywhere from 6 to 24 hours. And as you might guess, by the time a strike was actually authorized, the target had usually moved. Enter the Maven Smart System, or MSS. Maven is the AI powerhouse that takes those 6 manual steps we just talked about and completely automates them.
It constantly fuses incoming drone, satellite, and sensor data to process a staggering 1,000 targeting recommendations every single hour. It automatically generates courses of action, basically telling commanders exactly which asset should engage which target. And this isn't just a concept. It's actively utilized by over 20,000 users across major U.S. combat commands right now.
The results we're seeing from Maven are frankly unprecedented. Back in Operation Epic Fury, Maven compressed that entire traditional kill chain down to an average of just 86 seconds per targeting decision. 86 seconds. That speed enabled thousands of precise strikes in a matter of weeks. Now, naturally, this kind of hyper-efficiency sparks a pretty intense debate among experts. While the AI efficiency is absolutely undeniable, the question of whether an 86-second window truly allows for meaningful human control and oversight remains highly contested. It's a profound shift that places AI speed and human ethics into a very tight tension.
All right, Section 4, Deployment, AIP and Apollo. This is all about securing that software at the tactical edge.
So AIP, or the Artificial Intelligence Platform, is essentially Palantir's highly secure answer to the whole generative AI boom. It allows defense organizations to actually deploy things like large language models and AI agents securely inside their classified military networks. But crucially, and this goes right back to that ethical debate we just mentioned, it has strict human approval controls built right in. The AI might recommend actions or synthesize reports, but there is always a clear audit trail and a human is firmly in the loop before any action is executed. But here's a totally different problem. How do you safely push a software update to an AI model when it's literally sitting on a submarine hundreds of feet underwater? Well, that's Apollo. Palantir Apollo is their military software deployment system. It guarantees continuous updates across incredibly disconnected, extreme edge environments. So whether that software is sitting in a top-secret Pentagon cloud, in the back of a Titan Humvee, or deep under the ocean, Apollo ensures the front lines always have the absolute latest, most secure version of Palantir's tech. Let's move to Section 5 and see how this builds into an undeniable strategic defense advantage, looking at CJADC2 and some key market metrics. Palantir's strategic dominance really comes down to one thing. They connect everything. They've become totally central to the Pentagon's CJAD2 vision, which stands for Joint All-Domain Command and Control. It's a system designed to seamlessly link air, land, sea, cyber, and space assets together. On top of that, they're powering the software layer for next-generation autonomous warfare, including complex drone swarm coordination. And to handle all this data securely, they've actually partnered with NVIDIA to build sovereign AI infrastructure. These are highly secure military-grade data centers powered by advanced Blackwell systems designed explicitly for national security. And when you look at the financials, the validation of this tech is just staggering. Palantir secured a U.S. Army enterprise deal valued up to $10 billion. Their latest Q1 government revenue hit $687 million, representing a massive 84% year-over-year growth. Backed by a roughly $8 billion cash position, they are currently supporting over 685 distinct AI projects across the Pentagon. I mean, these aren't just little pilot programs anymore. This is massive, foundational enterprise adoption. So the crucial point here is the sheer scale of the budget shift we're witnessing. The Pentagon's AI investment has skyrocketed from $480 million to a massive $13.4 billion. When you look at that in the broader context of a $1.01 trillion defense budget for fiscal year 2026, it is abundantly clear that the Department of Defense views data and AI as being exactly as critical as physical munitions. And Palantir has masterfully positioned itself as the primary operating system to capture that multi-billion-dollar shift. Which brings us to the ultimate takeaway here. Palantir isn't just selling a vehicle, a radar, or a missile. They are selling the entire integrated defense ecosystem. You know, traditional defense contractors are amazing at building hardware, the jets, the ships, the tanks. But Palantir? They're building the digital nervous system that tells all of that hardware exactly where to go, what to target, and how to operate synchronously in real time. I want to leave you with this final provocative thought. As AI and software continue to compress the absolute chaos of war down to a matter of mere seconds, who truly holds the ultimate strategic advantage on the modern battlefield? Is it the side with the biggest weapons, or the side with the fastest, most integrated data? Thank you so much for joining me for this explainer. I really hope this helps you decode the incredible complexities of modern defense tech. Keep learning, and I'll catch you on the next one.